you just witnessed in the previous video was a result of dehydration. Over 175,000 cases of dehydration lead to hospitalization in a year alone in the U.S. This is a very prevalent issue in our society, as we are not educated on how to detect the signs and symptoms of dehydration before they result. The Biobelt fixes this problem.
For our Engineering 122 project, we have created the Biobelt. It has a conductivity sensor that reads the salinity of the sweat of the wearer and can turn on vibrating motors if the salinity is reaching a dangerous level.
The way it does this is through two 6mm vibrating motors, an Arduino Uno, and a conductivity sensor.
A healthy level of sodium is between 135 and 145 milliequivalents per liter. This is equal to 0.3334%. According to our calibration data, this corresponds to serial monitor output of 5.17. In our program, if the sensor value read on the conductivity sensor is less than the output, the motors do nothing, and the wearer can continue to exercise in a healthy environment. But if the sensor value read on the conductivity sensor is greater than the output, the motors will turn on, notifying the wearer that they are experiencing a potentially dangerous salinity level and possibility of dehydration.
Our Biobelt uses biomedical engineering and chemical engineering. For our first prototype, we used a very sturdy material that was adjustable for any waist size. Unfortunately, when exercising or running, this belt was too bulky and very uncomfortable, rendering it a not good fit for our product. We then created our final prototype, which is made out of spandex. This product is very comfortable, lightweight, and very flexible for anyone exercising or running. It has a pocket in the back where the components of the Biobelt are secured and stored, making for an easy and fun exercise.
These are our electrical components inside of the Biobelt pocket. First, we have our Arduino Uno, which is connected to a 9-volt battery, and we also have our breadboard. In the breadboard, we have two 6mm vibrating motors and our handmade conductivity sensor. The conductivity sensor is made out of two metal probes, a plastic backing, electrical tape, and shrink wrap. For our vibrating motors, we have a Carmex cap on the top of it so that they are still able to vibrate when pressed up against the wearer's skin. Now we're going to test our electrical components to show you how it will work in theory. First, we will use DI water. I will spray it on my skin and we will show you. Now the vibrating motor should not vibrate when the conductivity sensor is put against my skin. Okay, now we will do the same with the 1% salinity. Now when I put the conductivity sensor on my skin, it should make the 6mm vibrating motors vibrate. This is a good example of how the Biobelt will work, but instead of reading it from our hand, it will read it on the back of the wearer and be able to tell them when they are reaching a potentially dangerous dehydration level. Now that we have informed you of the dangerous problem of dehydration,
The future of your health and happiness lies in the Biobelt!
Push your limits, not your health. Wear this belt to save yourself.